In today's video, we'll be learning about the chain rule of derivatives. So, that means that when we have a function and another function inscribed with that function, we'll call this function the inscribed function g of x and the outside function f of x. So in this case, when we take the derivative of this type of function, the result is f prime inscribed g of x and then times the g prime of x. However, it's not always this simple because sometimes we can have multiple inscribed functions. And when this happens, we keep on inscribing those functions and then taking the derivative of the outside and then plugging the inscribed function back into the function, as we see right here. But we'll get to those examples later. For now, we'll stick to one outside function and then one inscribed function. So let's say, for example, if we had the function 2 of x plus 3 raised to the third power. So, as you can see here, when we do this, right, we end up getting that g of x is equal to 2x plus 3, while f of x is equal to x plus 3. Now, we can check that we've identified the outside function f of x and the inside function g of x by substituting for x g of x. So when we do this, we get 2x plus 3 raised to the third power. Okay, and that's exactly the derivative we are trying to solve right here. So our outside and inside function are correct. First, we take the derivative of the outside function. Okay, when we do that, we get 3 times x squared. However, we have to plug back in g of x, so we then get 3 times 2 of x plus 3 squared. Okay, and then times the inside function g of x, which is just, the derivative of the inside function g of x, which is then going to be equal to. So then our answer is just 6 times 2 of x plus 3 raised to the second power. Okay. I will now give you some examples that you can do by yourself. Alright, these are your examples, and try to pause the video and try to do them by yourself. Okay, so for the first one, the derivative of the outside function is this 2x, but then we have to plug back sine of x in. Okay, so as you can see here, if you just identify what g of x is and f of x is, it won't be too tedious. Now we have to take the derivative of the g of x, which is the sine of x, and that's just equal to cosine times cosine of x. So then this right here is your answer. For the second one, we take the derivative of the outside function, okay? And then we get 3x squared. We then have to plug back in g of x. Let me just write it down better. Plug back in g of x, and we get 3 times 8 of x plus 4 raised to the second power. Now we have to times everything by g prime of x, which is just 8. So then our answer is just 24 times 8x plus 4 raised to the second power. For the third one and final one, the derivative of the outside function is just 3 times tan of x squared. Now, the inside function, the derivative of the inside function is just secant x squared, since the derivative of tangent of x is just secant x squared. Okay, and this right here is your answer. So now that we have done a bit more challenging problems, let's get to a more tedious chain rule problem. In this case, we're going to use a lot of trigonometry, because trigonometry is known for being notorious in chain rule problems, and I'll show you why. So, let's say, for example, if you had derivative of sine of cosine of tangent of sine. Okay, yeah, we'll end it there. Okay, I think that's the amount of brackets we need. Yeah, it is. Okay, so now, how are we supposed to do this? Well, again, you keep taking the derivative of the outside function. Okay, so what is the outside function right now? Sine of x. Sine of x. What is the derivative of sine of x? Well, cosine of x. However, we're not done yet. We still have to plug in all these values right here. Okay? So when we do that, we get cosine of tangent of sine of x. And then, yeah, we can end it there. Okay? Now, we take the derivative of cosine, which is just negative x. Yes, negative sine of x. So, then we get negative sine of tan of sine of x. Sorry if that's a bit too small for you. Now, when we do that, we have to take the derivative of tangent of x. Okay, so that is tangent of x is just secant squared, okay, x. And then when we write secant squared x, remember, it's not just secant squared x, it's actually, if you substitute sine of x in there, since it's outside and we plug in the inside function, after we take the derivative of the inside function. Or, sorry, after we take the derivative of the outside function. Okay, and this is our last step, because all we have to do now is take the derivative of sine of x. So when we do that, we get cosine of x. So yeah, this is our answer right here. This is really our answer. It's a very big process, but if you just identify taking the derivative of the outside function first, plugging in all your inside function values, and then again timesing outside function times the outside function, plugging all your inside function values, and then keep doing that. Okay, so basically outside function values, then times take the derivative of the outside function values, and then times the derivative of the inside function values, and then outside, inside, outside, inside. It's like a kind of like a pattern. You'll get your answer eventually. But one could argue that you actually keep taking the derivative of the outside function values, and then you finally get to inside function sine of x. But you could just treat everything right outside, inside, outside, inside. Okay, but it's your preference. Okay, let's do our final problem. And in this case, we'll do the derivative of ln x raised to the 4th power. Pause the video and try to do this by yourself. Okay, so remember, this is equal to 4, right? the derivative of the outside function times ln of x raised to the third power times, what is the derivative of the inside function? ln of x, 1 over x. So then this right here, 4 times ln of x to the third power over x, okay, is our answer. That was the chain rule, and I'll see you in the next video.